Hello, my name is Adam Bringhurst. I'm a PhD candidate at Northern Arizona University in the School of Earth and Sustainability. And I'll be presenting a talk to you on modeling expert opinion through multi-criteria decision analysis methods to prioritize ephemeral channel restoration in the semi-arid forests of Arizona. Ephemeral stream channels in the semi-arid high elevation forests of northern Arizona are considered upland headwaters or wet meadows. Generally speaking, they only flow when there is a precipitation event, whether it be rainfall or snowmelt. And a healthy wet meadow ephemeral channel system would look similar to this, with a very small cross-sectional area of flow in the bankful area of the channel with wide spread across floodplain and wet meadow. The important features that these ephemeral channels through wet meadows serve to the forests of northern Arizona and other forests is their important hydrologic features. They move water, snow melt, rainfall. There are important geomorphic characteristics here, the slowing of water, the dissipation of energy, the storing of water. There's biogeochemical functions focused on the cycling of elements and compounds and nutrients, the dissolved organic compound or carbons. It's also very beneficial to plant community and faunal support and habitat. In the case of many of the ephemeral channels and wet meadows in the forests around this area, most of them are degraded. They've become deeply incised. Geomorphologically, they've been straightened out. They flow at high velocities. They scour sediment, and they no longer effectively store and cycle elements, compounds, or organic carbon. And because they don't soak water into the groundwater table there's no water storage, and the plant community has suffered as a result with extensive loss of riparian plants and habitat. So the good news is there's stream restoration efforts going on for these ephemeral stream channels in northern Arizona. They range from people out in the forest or in the wet meadows with shovels and wheelbarrows up to heavy equipment and machinery. The Forest Restoration Initiative, considered the largest landscape scale restoration initiative in the country at the time. It has a 2.4 million acre footprint. And in it, this is primarily identified as a thinning and burning restoration effort, which with the intention of reducing the risk of catastrophic crown fires. Fortunately, because of the NEPA process and through the EIS, they identified a suite of restoration activities that would also be implemented. And in that suite of restoration activities, they identified stream channel restoration. They identified 39 miles of ephemeral channel to be restored, which can be broken down into 163 different reaches of channel. And currently, Prioritization has put together a comprehensive implementation work group, and their focus is to identify sites for restoration and begin implementing restoration efforts. This is a map of the general restoration area of phase 1 for Forefry. And within this boundary are the yellow dots, which indicate stream reaches that are proposed to be restored. So in order to move forward and look into stream restoration efforts, and more specifically, methods aimed at selecting sites for restoration, I did a literature review, and I looked into planning for restoration, site selection, prioritization, many other key words. What I found that with respect to ephemeral channels, there are no documented or written about methods for selecting or prioritizing ephemeral stream channels for restoration. So instead, I moved my literature review efforts to look at perennial streams, wetlands, watersheds, riparian vegetation, and other ecosystems that are similar in nature. What I pulled from this literature review was that there are significant overarching goals that were seen across all methods in the literature. The need for explicit goals, not only to guide the restoration effort, but to go back and measure the level of success from a restoration effort. They also indicate the need for professional judgment and stakeholder involvement. So there's many different ways to narrow down and select one site for restoration. Most of them were about some form of scoring or ranking. The ones that seemed most applicable to ephemeral stream channels around here would involve some kind of multi-criteria analysis. So you weren't limited to one or two deciding factors. And then also the need for expert or professional judgment and stakeholder support. So I moved forward to find out how people are selecting sites for stream restoration in industry. And so I narrowed my search of practitioners of stream restoration to people working in ponderosa pine type forests around the West. The lime green area is the extent of ponderosa pine forest. I then looked at U.S. Forest Service areas that were coincident with the ponderosa pine type forest. And then I dug into their land and resource management documents, where they have a nice library of planning and projects that have been completed, and looking into any kind of restoration effort that was water related. I was able to find people that were willing to participate in some semi-structured interviews. So I got people from around the West: Washington, Idaho, Oregon, Colorado, California, New Mexico. The key interview questions I asked them, I outright asked them if they were doing any type of ephemeral stream channel restoration work. And then I asked them to, with respect to one specific restoration project, how they selected that site for restoration. And then I asked them to verbally explain their 5 top reasons. And then in the end, I also asked them to give me any advice for working with stakeholders. Taking the results of these semi-structured interviews, I coded their responses and I analyzed the data, and this is what I came up with. These are deciding factors that the interviewees discussed when in reference to the specific site they were referring to for restoration. And the left column here, access, fish, physical, future plans, needs a little bit of discussion. The access was, these concepts have been put together for presentation of data purposes. Access referred to road access, whether it was easy to access by road, also public versus private lands, and then if there was any kind of infrastructure in the way of restoration. Fish, many of the people that I interviewed were doing stream restoration specifically for salmon. And so it's very important to them to consider habitat and water quality, temperature, usually the main water quality parameter. The physical refers to areas that would increase groundwater recharge, areas that would have low slope or lower velocity stream energy, and then areas that had good potential for floodplain access. They also, with respect to future plans, they discussed things like resilience, and especially resilience in the face of projected change, resulting from climate change models and scenarios. And then many of them also referred to Forest Service management plans. Many of the Forest Service agencies have a management plan that identifies restoration goals specific to watersheds and stream channels. And so they referenced that, and that's been here into future plans. Biological is anything that had to do with biodiversity, habitat, riparian areas, and then multiple species. And watershed, here they discussed considering things at a watershed scale, especially processes throughout the watershed that might be leading to degradation. They also discussed the need for increasing connectivity and then the maximum area restored. Then moved on to ask them to identify the most important reasons for selecting any stream channel site for restoration. And in part of the interview, I would explain to these practitioners of restoration that we're planning to do stream channel restoration and ephemeral stream channels that hold no fish. And they still couldn't get past the idea of doing stream restoration for something other than fish. One, it was a driving factor of where they get their funding. And two, it's just such a need in the Northwest in those stream channels that run into the ocean. So they still, even in the face of me telling them we're doing ephemeral stream channel restoration, they said, well, fish are still a big priority. Now, again, the grouping of this data matches those from the previously presented. So I'm going to skip ahead down to the very bottom one where there was a new piece of data added here, and it was water. And this is someone put a priority on selecting stream channel sites for restoration that would feed water into a municipal reservoir or a watershed that feeds into a municipal reservoir. Looking at the data from specific site to any kind of general site, and I'm saying general site in a vein of what we could apply this to any stream channel restoration selection effort. And you can see some of them went, they became less important, access and even fish a little bit. And then the physical future plans stayed the same, but what went up in importance was the biological considerations and then the watershed approach, where cost and water both stayed the same. What I've done is I've taken the results of these interviews, and I created a fundamental objectives hierarchy. And I know some of the text on this slide may be hard to read, but every one of these will be presented on its own slide here in a moment. But the fundamental objectives hierarchy is a decision matrix that can be used to measure attributes at stream sites and then eventually narrow down a priority reach for restoration. What I've done now is moved with this fundamental objectives, and I've presented it to professionals and stakeholders that are associated with FORFRI, the Forest Restoration Initiative. And in FORFRI, they've identified the Comprehensive Implementation Work Group, whose goal, again, is to identify sites for restoration and start carrying out restoration efforts. So I moved into another round of methods where I'm doing more semi-structured interviews. And these are the results of a second round of interviews. When asking people where they would put their priority was to start at the watershed scale, identify watersheds first, and then once within there, then look at the channels. This was again, preliminary data. The way that the attributes that were used to measure a priority watershed were based on, this is again, the regional professionals and stakeholders. And what was most valuable to them was whether the watershed fed a municipal watershed or was a municipal watershed, 34%. Other things that were of importance to them were downstream risk. because of the big fires that we've had in our forest in the last several years. Flooding has become a significant issue, and restoration efforts are now being used more frequently to reduce flooding impacts. This Forest Service plan priority is based on Forest Service management plans and priority fire sheds and watershed condition framework. The watershed condition framework is a framework that the Forest Service has developed to prioritize watersheds for restoration. With respect to priority channels, the way that our professionals and stakeholders put their values on access and infrastructure issues, biological characteristics, wet meadow characteristics, degree of degradation, and connectivity and length. And again, this is preliminary data that I need more data to take it any further. So the rest of the discussion won't show any more results from interviews, but I will discuss how each of those were measured. So access and infrastructure is a measure of downstream risk, a measure of land ownership. It's not as big of a deal to us here in Fry because all of the sites that are identified for restoration are within national forest boundary, not on private property. Road access is another issue, and then other infrastructure is this component of items that might be in the way of restoration, such as culverts or bridges or roads that are prohibiting effective restoration efforts. Degree of degradation is an important consideration. Really, there's no sense in doing restoration work where there's no need for it. And likewise, there's less efforts put at restoring really, really highly degraded systems because the cost and effort doesn't meet with the benefit. So the next one was wet meadow characteristics. I asked the attributes that we're looking at here is the area of the floodplain, which is the complete wet meadow area around the stream channel that can be looked at as means of groundwater storage. So maximizing groundwater storage, slope and stream energy again are being looked at, and then floodplain access, the ease for restoration efforts to put water back onto floodplains. Biological characteristics, here we have riparian area and then select species. Now select species is in here because the people that had such a high value for fish, even though we don't have fish, I decided could be modeled for other select species, whether it's an endangered species or even critical habitat identified by the Endangered Species Act. Around here, a lot of select species that are prioritized, that are used as priority site selection methods are elk. A lot of people like the elk around here and they want to restore sites that benefit primarily the elk. Connectivity and length, again, two attributes that are important to measure. The closeness of two sites, one to another, there's a big value in that. And then the overall length of reach, some people are measuring this attribute as, you should restore the place that does the most general area or length of reach restored. Again, this is the fundamental objectives hierarchy as it's being developed through semi-structured interviews. And the goal is to take all of this data that's being collected through the values of stakeholders and professionals in this regional area, put it into a spatial analysis tool that will take layers such as stream reaches, watersheds, the watershed condition framework, firesheds, locations of culverts, species distribution, riparian area maps, LiDAR and photogrammetry. Other things we're doing is putting in code to determine wet meadow areas and distance between two sites to improve connectivity, and then distance between roads, whether they be paved or dirt. And then one of the other interesting factors we're looking into is whether depth of incision as determined through LiDAR or photogrammetry can be used as a method of identifying degree of degradation from spatial analysis tools. So the end goal is to develop an explicit and repeatable prioritization tool for ephemeral channels. It definitely has to be based on professional judgment, has to be based on stakeholder involvement. We're lucky that the Quantify has put together a comprehensive implementation work group that's combining both professionals and stakeholders. And then the big thing here is that even though ideally ephemeral stream channels around the West and around the globe could be restored using a tool like this, it is very regionally value based. So someone in Oregon or Texas or anywhere in the world may have different values and different weights for the attributes. I'd like to give special thanks to Dr. Danielle Perry at NAU, my committee chair, who's the head of the Free Flowing Rivers Lab. I'd also like to thank Quantify and Coconino National Forest, Northern Arizona, the comprehensive implementation work group, and then other interview participants that have supported me in my research. And I hope you enjoyed this video version of this presentation. If you have any questions, my contact information is available through RMS. Thank you. Goodbye.